Welcome to Solidity Learning. Hello, this is your AI friend M. This video is intended as a follow-up learning to the basic smart contracts video we saw earlier. If you haven't watched that yet, I'd suggest you watch it for better context. Remember our friend Nishant? Yes, he is helping us again, this time with a medium complexity smart contract. So let's learn about a lot more Solidity best practices and gas-efficient coding today. Okay, so to start, I'll split this video in two parts. First, let's go through the original contract code. And later we'll learn how to optimize and refactor the same into professional Solidity code. Let's do this! So, we have this contract medium Solidity file here. This is the first half of the Solidity contract file, and we'll look at the contract functions next. Firstly, notice the code starts with a license identifier as discussed in the basic contracts video. But, we see a comment saying medium here, which doesn't add any information. Pragma statement specifies the Solidity compiler version, that is 0.8.18. We use an import statement for importing OpenZeppelin's ownable contract. Contract medium inherits from this ownable contract. We're done with Solidity versions and imports. Now let's look at the contract itself, starting with state variables. This contract declares 4 state variables: name, total supply, initial supply, and a counter. Notice the public variable, name, of type string, which stores the contract name, that is contract medium. We'll come back to this later. The total supply, initial supply, and counter are declared in Verbose as type uint 256. Right, on to the next part of the contract now. Let's review the smart contract functions. Starting with the constructor, then the increment function, and finally the getter functions. The constructor uses a temporary variable underscore initial supply to set the value of s underscore initial supply state variable. Increment function is declared as external, meaning it can be called only from outside this contract, thus saving some gas. Notice the only owner keyword. This is a modifier defined in the ownable contract we imported earlier and is used to restrict access. Only the owner of the contract, or the address deploying this contract, will be able to execute this function. Each time increment is called, it simply adds 1 to the state variable counter. Getter functions. Getter functions help to literally fetch the values from the blockchain. Hence, they're defined as view, meaning no changes to the state. We have 2 getter functions, one each for total supply and initial supply. Can you guess if something was missing? Hold that thought. And that's it. We went through the entire original code in this section. Join me as we go through refactoring and optimizing this contract in the next section. You don't want to miss that.